So this is the second video about the proof technique called mathematical induction. The first video explains what it is and how to use it and gives an example to prove an equality. Here I'm just going to use it to prove a more interesting example. So I'm not going to explain what it is again. If you need a refresher, you can pause the screen here or watch the previous video. But I'm going to use the same proof technique to prove what I think is a more interesting problem. So here's the problem. We want to prove that the angles of any n-sided convex polygon adds up to 180 times n minus 2 degrees for all n is greater than or equal to 3. So this is a property. So this has the same form we were talking about. We have a property p of n, which is defined for integers. That's this property right here, and it's defined for integers because a polygon can only have an integer number of sides. You can't have a polygon with 1.5 sides. And then we also have, we're trying to prove the property p of n for all integers n is greater than or equal to some base integer a. Here we have our base integer a equals 3. So this is of the form of the type of problem where you can use mathematical induction. So I'm going to use it. The only thing you have to know is what is a convex polygon. Well, a polygon in geometry is a sequence, a chain of line segments that connect in a cycle. So for example, a triangle, line segment, line segment, line segment that connects back to the beginning. Same with a square, pentagon. These are chains of line segments that connect in a cycle. That's what a polygon is. Now, a convex polygon means that given any 2 points on, meaning around the border, or inside the polygon, the line joining the 2 points lies entirely inside the polygon. So basically I have some examples here of what's a convex polygon and what's not a convex polygon. These are all convex polygons because any 2 points anywhere on the border or inside, you draw the line between 2 points is contained within the polygon. But for example, these are not convex because let's say you pick this point and draw a line between them. This line lies partially outside of the polygon. This one's not convex because let's say you pick this point and this point, the line between them is entirely outside the polygon. So if any or all of the line is outside the polygon connecting to the 2 points, it is not convex. So this property only applies to convex polygons, this type right here. So basically, in order to prove anything by induction, you need the base step and the inductive step. So here we start with our base step where we prove that the property p of n is true for n equals a. A in this case is 3. So base step, n equals a, or 3 in this case. Well, a polygon with 3 sides is a triangle. So we have, here's our triangle. And I won't prove it here, but it's a fact of geometry that the angles of a triangle add up to 180. So this angle plus this angle plus this angle equals 180. So we have angles, so sum of angles of a triangle equals 180 degrees. So we want to prove that when n equals 3, the angles of any 3-sided convex polygons adds up to 180 times n minus 2. So degrees. So 180 times n minus 2 degrees when n equals 3 is 180 times 3 minus 2 degrees, which is equal to 180 times 1, which is equal to 180 degrees. So as expected, this holds because the sum of the angles of a triangle is 180 degrees. And we proved the base case. So now we have to prove the inductive step. Now remember, we're going to assume the inductive hypothesis that it's true for n equals k, and then we're going to assume it's true for n equals k, and then prove that it's true for n equals k plus 1. So what we are assuming, p of k, in other words, we are assuming that the angles of any k-sided convex, that's important, polygon add up to 180 times k minus 2 degrees. This is what we're assuming. And we want to prove p of k plus 1. In other words, the angles of any k plus 1 sided convex polygon add up to 180 times k plus 1 minus 2 degrees. So we assume this, we're trying to prove this. So we're going to say, we're going to get our k plus 1 sided polygon here. I mean, it's kind of hard to draw something general, but I'll do my best here. Let's say we got some sides, and then, this continues. Let's give some dot, dot, dots to show that there is some other amount of sides here connecting back to the beginning. And we'll say it has k plus 1 sides. This is our k plus 1 sided polygon, right? Line, 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 some other number of lines connecting back to the beginning, and in total there is k plus 1 sides. So now let's draw a line here from here to here, and then we'll shade in this part of the polygon. We're just going to kind of split off the polygon into two convex polygons. So we're just drawing a line and separating them into two polygons. This one side's a triangle, so this has 3 sides. Now, this part of the polygon has k sides because it was k plus 1 sides, but we're turning these 2 sides into just one flat side. So we're turning 2 of the sides into one side, making this a k-sided polygon. So now we turned our k plus 1 sided polygon into a k-sided polygon and a 3-sided polygon. We know that the sum of the angles in a 3-sided polygon or a triangle is 180 degrees. Now, here's where we use our inductive hypothesis. We have a k-sided polygon. Well, we're assuming that the angles of any k-sided convex polygon add up to 180 times k minus 2 degrees. So the sum of these angles in this k-sided polygon, sum of angles equals 180 times k minus 2 degrees. So what is the sum of the angles in our k plus 1 sided polygon? Well, it's the sum of the angles in our k-sided polygon plus the sum of the angles in our 3-sided polygon. So sum angles k plus 1 equals sum angles k plus sum angles 3. All right, this is equal to the sum of the angles in our k-sided polygon, which is 180 times k minus 2, plus the sum of the angles in our 3-sided polygon, which is 180. So the sum of our angles in our k plus 1 sided polygon is 180 times k minus 2 plus 180. Let's pull out the 180. So this is equivalent to after pulling out the 180, it's 180 times k minus 2 plus 1. And then we can rewrite that as 180 times k minus 2 plus 1. Basically, we just got rid of the parentheses. And then I'm going to rearrange it again and say it's equal to 180 times k plus 1 minus 2. Basically, I just rearrange the order that these terms appear. And now I can add parentheses to group this guy right here. So it's 180 times k plus 1 minus 2, which if you look at what we're trying to prove, this is what we're trying to prove. we want to prove that the sum of the angles in a k plus 1 sided convex polygon is equal to this many degrees. And if you look down here, that's exactly what we ended up with when we substituted the inductive hypothesis. So we proved the inductive step. So we proved the base step and the inductive step, which means we proved our original statement that the angles of any n-sided convex polygon add up to 180 times n minus 2 degrees for all n is greater than or equal to 3.